Now then, this is Pick Computing, A-Level Computing Video 23, Part 1, where we're going to look at binary addition. So the first thing we need to think about when adding binary might be to remember how we do it if we're adding decimal or denary. So if I take a simple sum like 19 plus 26, I know that I've got to add up my right-hand side digits first. If they come to over 9, means I have to carry 10 over into the next column on the left. So let's see how that works. 9 plus 6 we know is 15, so I put a 5 at the bottom of that column, and then I've got to carry a 1 over into the next column. Then I can finish off my sum by adding up the left hand side column. Becomes 45. So it's key to remember what we do there for adding up binary. But binary, as we know, is either ones or zeros. So an example of binary is there, a set of 8 ones or zeros, and that particular combination actually converted to denary is 246. When adding binary, we don't carry tens like we did in the first example on this video. We actually carry ones, and we'll see how that works. So a binary addition that we might want to try might look like that: 1010 plus 0101. So we lay it out the same as we do a decimal addition. But what's useful is if we write the binary number system at the top as well, starting off with 1 on the right hand side, and as we know we double it each time. We only need to go as far as 8 with this sum though, because we've got two 4-bit binary numbers that we're adding up together. What's also useful, if you can remember this for an exam and write it in rough on your exam paper, even better, is to remember some binary addition rules. So we have a column for the digits we're going to add up. We have a column for the sum of the binary digits, and we have a column for any digits we might need to carry across. So our rules are: if both binary digits are 0, so if we think about two digits above each other, we need to add them up. If they were both 0, then the sum would be 0. We'd write 0 underneath, and we'd carry 0 over to the next column. If it's 0 we're adding together, then the sum is 1, so the answer underneath is 1, and we carry 0. And that's the same either way round, whether it's 0 plus 1 or 1 plus 0. So in our example, we've got 0 plus 1, so if we look at our table, the sum is 1, so we write that underneath, and we carry 0. But we don't need to write 0 up above the 1 here. If you're carrying 0, you just do nothing. So 1 and 0, again, if we look at our rules table, is sum 1 carry 0, and it's going to be the same all the way along. They're all 1s plus 0, so we come out with 4 1s. How can we check that's right? Well, if we take the 1010 and look at its binary number system equivalents, we can see that we'd use 8 and 2. So 1010 is 10. 0101 will be 4 and 1, which is 5. Those two things added together, of course, are 15. Are 4 1s in binary 15? Well, 8 plus 4 is 12, plus 2 is 14, plus 1 is 15. So yes, we got that one right. So we've got the right answer, but we haven't necessarily used all of the binary addition rules that there are. If we look at a harder example, which might be 1101 plus 1111, again we've got our binary number system up at the top. I've gone a step further, so we've doubled 8 to get 16 as part of this, and you'll see why in a minute. But straight away, because we're adding 1 and 1, we haven't got that in our rules table. So we need to add into our rules table what is the result of 1 plus 1. Well, the result is the sum is 0, so we'd write 0 underneath, and we'd carry 1. So there goes the 0, and we carry 1 like that. Now we're left with 1, 0, and 1 to add up this time. So we add that into our rules table, and the result of that is the same as 1 plus 1, because we just forget about the 0. So it's sum 0 and carry 1. So it's actually the second column here is the same as the first one. And it doesn't matter which way we write it round, 1 plus 0 plus 1, or 1 plus 1 plus 0, or 0 plus 1 plus 1. It's always sum 0, carry 1. The other rule we need to know, and you'll see in a minute why we need this one, is 1 plus 1 plus 1. And this one, you get a sum of 1 and carry 1. So it's different from the ones above. So 1, 0 and 1 we know is 0 and carry 1. Here comes the 1, 1 and 1, which we know is 1 and carry 1. There's another one, 1 and carry 1. Now this time we're just left with 1 by itself, so that means we need a 1 there as well. Checking it, 1101 in decimal is 13. 1111 is 15. Added together, we get 28. And 16 plus 8 plus 4 is also 28. So we've got that one right as well. A key thing really here to remember are these new rules that we've put in, where 1 plus 1, or 1 plus 0 plus 1, or 1 plus 1 plus 0, or any other combination like that, always has the same rule, that it's a sum of 0 and carry 1. And the final rule that we need to remember is that if you've got 3 ones added together, it's sum 1, carry 1. Overflows are something we should talk about. 8 bits, for example, we've got 8 bits there. The highest denary number we can express in 8 bits is 255, which is actually all ones, 8 ones in a row. The decimal equivalent is 255. So if we try to add up 2 lots of that, and we use our rules, I'm not going to go through all the working now, you could do this for yourself, but you should come out with a 9-bit answer. Now when you get a 9-bit answer, you overflow from the byte data type, and you might notice that in your programming at some point, because the byte data type only allows 255 different numbers, but here, because we're adding up 2 large binary values, we actually end up with 9 bits, and that could cause an overflow error. But it wouldn't have to be 8 ones plus 8 ones. It could be something random like this. Would still give us a 9-bit answer and an overflow. Why don't you pause the video at this point and try some of these calculations for yourselves. Remember to try and write out and use your binary addition rules. So I'm going to leave that blank for you so you can have some practice at writing out the rules also. Bye for now.